The central limit theorem basically tells us that if all samples of a particular size are selected from any population, the sampling distribution of the sample mean is approximately a normal distribution. Here, I highlighted the word particular size is because central limit theorem prefers a larger sample. And as a general guideline, the normal distribution approximation is justified when n is at least 30. To have an illustration of the sample distribution, let us use the diagram here. The first diagram shows us a population where the distribution is showing a symmetric distribution. As we draw a sample of 2, the distribution is also symmetric, but the dispersion is still large. As the sample grows larger, it is approximating to a normal distribution with a smaller dispersion. But it's obvious here because the population itself is already symmetrically distributed. The second diagram here shows a population that has a negative skewness. As we draw a sample with larger numbers of sample, it will approach to a normal distribution. We can compare when n is equal to 2 and when n is equal to 6. When n is equal to 6, it starts to have a symmetric distribution. But as n gets larger, the dispersion or the standard deviation becomes smaller. And on the next diagram here, we have a uniform distribution for the population. A sample drawn from a uniform distribution population will have a symmetric distribution. So although the n is 2, it already has a symmetric distribution. But as the sample grows larger, the dispersion becomes smaller. On our last diagram, it is similar to the second diagram, except it's positively skewed. We can see here, as the n gets larger, the sampling distribution will follow a normal distribution with a smaller variance. This is the main point of central limit theorem. It shows that as n gets larger, the sampling distribution will approach a normal distribution, and the dispersion, which is measured by the standard error of the sampling, becomes smaller, which is preferred when we do statistic inference or inferential statistic. Now we can conclude that sampling distribution of the sample mean will follow the normal probability distribution under two conditions. First, when the samples are taken from population known to follow the normal distribution. In this case, the size of the sample is not a factor. When the shape of the population distribution is not known or the shape is known to be non-normal, but our sample contains at least 30 observations. We should point out that the number 30 is a guideline that has evolved over the years. In this case, the central limit theorem guarantees the sampling distribution of the mean follows a normal distribution.